Hello, George Romanic here. Today I would like to talk about modulo operator or modulus operator. This operator is extremely useful and we use it quite often in coding and programming wherever we have to process some data that have some circular periodicity or they wrap around some reference value, and the classical example in atmospheric sciences would be wind direction data. We know that wind direction data typically go from 1 to 360 degrees, and then after 360 degrees the wind direction wraps around 360 and we again have 1, 2, 3, 4 and so on. So if you get wind direction 370 degrees, you know that it should be actually 10 degrees wind. But it will be more clear what I mean by that when I start a lecture on modulo operator and how we use it. I decided to make this video on modulo operator for two reasons. First, I hope it will help you process these types of data that go around some reference value. And two, I noticed that many people use modulo operator without knowing the mathematical background, machinery, so to speak, behind this function. And this is, I believe, actually normal because today's programming languages, Matlab, Python, R, whichever one you use, have already built-in functions for pretty much all typical mathematical operators and functions, and we can use those functions sometimes without actually knowing how they work. Another typical example of this not properly understanding function but using it would be standard deviation. I'm not gonna talk about standard deviation today, but I believe that many people know intuitively at least what standard deviation is, but if you would give them a set of data and say, okay, calculate this on a pen and paper, perhaps not many people would be able to do it. I'll have a video on standard deviation sometime in the future. But today's I would like to fill a gap maybe in the knowledge of modulo operator and show you how to use it and what is the mathematical machinery behind this operator and this function in computer codes. Let's start. Before making generalizations, let's run through an example that I hope will simplify these concepts. I have two numbers, let's say 17 and 3. What is modulo of 17 and 3? We use mod to represent modulo, and when we write it like this, the first number is called dividend, the second number is divisor. This is how I would explain modulo of 17 and 3. How many times 3 goes into 17? Answer: 5 times, because 3 times 5 is 15. The difference between 17 and 15 is 2, and that is the result of this modulo operation. Let's take another example. Let's try to calculate modulo of 395 and 360. How many times 360 goes into 395? Answer: once, because 2 times 360, you will notice, is already 720, and that is above 395. 395 minus 360 is equal 35. Therefore, the result of this is 35. I picked this second example because it is related to our lectures on wind direction. You will remember that wind direction goes from 1 to 360 degrees or 0 to 359. That depends on the acquisition software that you use to record wind direction data, where 360 degrees is north wind. So why is this modulo operation useful to deal with wind direction data? Well, let me demonstrate that with another example. Let's say you are adding wind directions and you say 90 degrees plus 135 degrees plus 45 degrees plus 180 degrees. By the way, this would be east wind, this would be southeast wind, this would be northwest wind, and this would be south wind. If you sum these four numbers, you will get 450 degrees. But wind direction runs up to 360 because this is north. So what would be 450 degrees wind direction? Well, you can find this angle, so to speak, manually using windrows. You will remember that here is 0 degrees or 360 degrees. Here is 90 degrees, 180 and 270 degrees. So what would be 450 degrees here? Well, you start from here and you go 360, but to reach 450 you still need 90 degrees. So you can see that 450 is basically equal 90 degrees on this windrows. However, instead of plotting and counting how many times we go around the circle, we can figure out that 450 degrees corresponds to 90 degrees if we use modulus operation. We would say mod of 450 and 360 is equal 90. How do we know it's equal 90? Well, we ask ourselves question, how many times 360 goes into 450? Answer is once. And then the difference between 450 and 360, well, 450 minus 360 equals 90. And that's exactly this example, this result that we got here. You will agree that this was very simple example and you could indeed plot windrows and do this manually. However, what happens if you need to add 20 of these numbers and you end up with wind direction that is, for example, 4,340 degrees? Are you gonna go 10 times around this circle to figure out what this direction corresponds to in terms 0 to 360? Well, that would be time consuming and difficult. Instead, we can use mod operation. So mod, and you will see that this result is 20 degrees. How do we know it's 20 degrees? Well, we ask ourselves question, how many times 360 goes into 4,340? The answer is 12 times, because 12 times 360 is equal 4,320. And then the difference, 4,340 minus 4,320 is 20. And that's exactly the result that we obtained using modulo operation. Now I would like to generalize this. We say that B is modulo of A and M, where A is called dividend and M is called divisor. B mathematically is equal A minus M times round down of A divided by M. Now, this strange bracket is called round down of this number over here, also known as floor operation. So if I have a number, let's say 15.9, round down of this number is 15, not 16 as usually people would round it. For example, round down of minus 15.9 would be negative 16. So we are rounding towards negative infinity with this operation. As a side information, of course, there is also round up operation denoted like this. And for example, round up of, let's say, 14.1 would be 15, not 14. But in this case, when we are talking about modulus, we are using round down. So let's run this example using this formula. We will have that B is equal A, which is 4340 minus M, and that is 360, times round down of 4340 divided by 360, and that would be 4340 minus 360 times, if you make this division, you will get 12.0556, and that is equal to 4340 minus 360 times, I round down this to 12, and that is equal exactly 20, if you make this calculation, which is the result that we obtained here. Lastly, I would like to mention another useful application of this modulus operation, and that is in coding. I will write it here. We use it quite often in if loops. Let's say you want an if condition which will depend on whether or not the input number is divisible by 17. So you would say, let's say input number we denoted by n is equal 187, just as an example. You can pick your own number. You would say if mod of this number, which is input, and 17 is equal 0, display subscribe, else display go watch beauty bloggers. End.